All right, let's take a look at some of these quadratic function problems. And for the very first question, we need to state the following key features for this quadratic function. All right, so remember, any quadratic function has a degree of 2. And for this particular question, this is written in vertex form. So this right here and this right here, that kind of tells us the vertex of this parabola. So the vertex of this parabola is going to be 4, negative 1. And because we have a positive leading coefficient there, this thing opens up. Okay, so before we even do this question, you can kind of create a very light sketch of what's going on. So the vertex is at 4, negative 1. So roughly this could be perhaps 4, negative 1. And this parabola opens up. So maybe the graph looks like this, for example. Okay, let's go ahead and now start answering the questions here. So the vertex here, as we mentioned, is going to be 4, negative 1. The domain for any quadratic function is all real numbers, so x in R, xer. And the range is, well, look at the graph there. So the graph here, it has a low height of negative 1, right? And it opens up. So whenever the graph opens up, the range is always going to be greater or equal to, and then we put the y variable on this side, and what is the lowest height? The lowest height is negative 1. So the range is y is greater or equal to negative 1. All right, so the range is y is greater or equal to negative 1. The x-intercepts. Okay, so for this one, we need to figure out what the x-intercepts are. And for the x-intercepts, visually on the graph, the x-intercepts are these points right here. So it kind of looks like we have two x-intercepts, right? And when we're solving for the x-intercept, this happens when the y value goes to 0, right? So here's your y. You set that equal to 0. And you have bracket x minus 4, bracket squared minus 1. So you're solving this particular equation. All right, so there's a negative 1. I want to bring that over, so that becomes positive 1. And I have x minus 4 squared. And if I want to get rid of this square here, we just take the square root of both sides. All right, so when we take the square root of both sides, well, the square root of 1 is just 1, but it's actually plus or minus 1. And then we have x minus 4 over here. And then from there on, we just take this negative 4 and we bring it to the other side. So now we have plus or minus 1 plus 4 equals to x. Okay. If we go ahead and figure this out, plus 1 plus 4 is going to be 5. So my x-intercept is going to be at 5. And I also have negative 1. So negative 1 plus 4 is going to be positive 3. So my x-intercepts are at 5 and 3. So if I write that correctly here, my x-intercepts are at 5, 0, and 3, 0. All right, so there you go. That's how you find your x-intercepts. All right, so a little bit of work there to find the x-intercepts. So let me just erase this now. All right, and now we need to find the y-intercept. Okay, so the y-intercept, this happens when x goes to 0. So now I have y equals to bracket 0 minus 4 all squared minus 1. And this is y equals to, well, 0 minus 4 is going to be negative 4. So negative 4 squared minus 1. Negative 4 squared is going to be 16. Then I subtract the 1 and I get y equals to 15. So technically this is going to be 15 right there. That's the y-intercept. So the y-intercept is going to be 0, 15. The axis of symmetry, this one's not too bad. So the axis of symmetry, we always need to start off by saying x equals. And it's really just the x value of the vertex. So x equals to 4, that's your axis of symmetry. And it's congruent equation here. There's different ways you can write this, but since we have a leading coefficient of 1 here, we can just write this as y equals to 1x squared. Okay, so what we're saying is that this parabola here has the same shape as the general parabola. Okay, let's move on to question number 2. All right, so same kind of question, but now we're given the quadratic function. Remember, it's a quadratic function because we have a degree of 2. But this time it's not in vertex form, right? So we can't find the vertex right away. When it's written in this form, we definitely want to complete the square. But one thing that you can do right away is you can definitely find the y-intercept. All right, so the y-intercept, we just let x be 0, right? And we're just given positive 9. So we can actually find the y-intercept actually very quickly here. So the y-intercept is 0, 9. All right, so we can't find the y-intercept quickly like that in the very first question, but in question number 2, we can definitely find the y-intercept right away. And the domain, we know the domain for any quadratic function is XER. All right, so those are 2 things that you can do pretty much right away. And one more thing that I see that we can do right away is probably the congruent equation here. So take a look at the a value. The a value here, or the leading coefficient, is -3. So we can say that the congruent equation is equal to the leading coefficient, which is -3, and has the same shape as this parabola there. Okay, so those are some things that we can do right away, and let's see if we can figure out the rest here. Okay, so let's go ahead and complete the square here. So our leading coefficient is -3, right? So when we're completing the square, we need to factor out the leading coefficient, and the leading coefficient is -3. And we factor that from the first 2 terms, all right? So this is my first term, and this is my second term, right? So we're going to factor out -3 from the first 2 terms. If I do that, I get x squared, and then I get plus 2x. Right? So you can always verify that your initial steps are correct by just distributing. So if I distribute that, I get this. If I distribute that, I get that. Okay. All right, so once we factor out the leading coefficient from the first 2 terms, the next sign is always a positive sign. Then I'll leave a little space here. Then I'll close the bracket, and then this plus 9. And then this plus 9 tags along. Okay, and then from there, we just take the middle number, which is positive 2, and then we divide it by 2, and then we square it. All right, so 2 divided by 2 is 1, and 1 squared is equal to 1. So there's a 1 here. Okay, now the problem here now is if I go back to this, if I distribute this, I have a -3, right? So -3 times 1 is -3. So to undo that, I need a plus 3 over here. Okay, so that's how you complete the square, the initial steps, and you can always kind of verify your work by just checking to make sure that the line is equivalent to the first line. So here's my 9. I mean, this times this is that, this times that is that, this times this is -3. If I add the plus 3, that cancels out. So mathematically, that's the same line as the very first equation. Okay, now that we've completed the square there, let's go ahead and factor this. So the -3 remains. I'll put a squared there. All right, so since I have 2 positive signs in blue, I have x plus, and all we do now is we take this middle number. This middle number is 2, and we divide that by 2. So 2 divided by 2 is 1. And then finally over here, 9 plus 3 is 12. All right, so there it is. And from here, we can definitely find the vertex. The vertex is right there. So the vertex is going to be -1, 12. Let's find the range here. Okay, well, the range, well, this opens down here, right? It opens down. So if you want to visually think about this, where's the vertex? Well, the vertex is over here, -1, 12, and it opens down, right? So if it opens down, it's going to be y is less than or equal to, and then we just take the y value there, which is just 12, right? So the range is y is less than or equal to 12. Okay, and then finally we got to find the axis of symmetry. Well, axis of symmetry is just the x value of the vertex, which is -1. That's not too bad. And then we got to find the x-intercepts, right? So different ways you can do this. Let me kind of erase this here. If you have your answer in vertex form like this, we can find the x-intercepts by letting y equal to 0. And then we just solve this particular equation. Okay, so we take our plus 12, we move that to the other side, so I get -12 here. All right, and then since we have a -3 here, we can divide both sides by -3. All right, so -12 divided by -3 is going to be 4, and that cancels off, and I have bracket x plus 1 bracket squared. From here, if you take the square root of both sides, the square root of 4 is 2, but remember it's plus or minus 2 equals to x plus 1, and then we just subtract 1 from both sides. Right, we subtract 1 from both sides. All right, so 2 minus 1 is going to be 1, and -2 minus 1 is going to be -3. So those are our x-intercept values, -1 and -3. So if you want to write your x-intercepts as 1, 0, and -3, 0, those are your 2 x-intercepts. All right, so that's a very good question to kind of get started here. And let's go on to the next question. And for this one, I need to find the x and y intercepts. Once again, if you want to find the x-intercepts, you just set y equals to 0. And if you want to find the y-intercept, you set x equals to 0. Okay, so let's go ahead and find the x-intercept here. So we set this equal to 0. Okay, so let's go ahead and solve this. There's a plus 3, so that becomes negative 3. Actually, hold on. I can tell right away this is not going to work out. Remember, what's the vertex here? Well, the vertex is going to be negative 1 and 3. So if I look at the vertex here, here's negative 1 and 3. And because there's a positive leading coefficient, this thing opens up, right? So it turns out that there are no x-intercepts. All right, so the graph never touches the x-axis, which is this blue line, so there's no x-intercepts. Okay, now we need to find the y-intercept. And for the y-intercept, we need to set x equals to 0. So if I rewrite the equation down here, if I want to find the y-intercept, I have 2 bracket, and then we just change the x value to 0. And then we have the plus 1 squared plus 3. And we just solve for y here. Okay, what's 0 plus 1 is just 1. 1 squared is 1. 2 times 1 is 2, plus 3 is 5. All right, so the y-intercept is 0, 5. And that's it for that question. Let's move on to another one. Okay. So for this question, we need to state the following key features of this quadratic function. It's a quadratic function because it looks like a parabola, and in this graph, it's opening up, right? It's opening up. Okay, right away, I know the domain. So the domain for any quadratic is XER, all real numbers. And after that, let's find the vertex. The vertex seems to be down here. So we need to actually count where that vertex is. So 1, 2, 3, 4. So this is 4, comma. So we have negative 15, negative 16, negative 17, negative 18. So it looks like it's 4, comma, negative 18, just by kind of inspection there. So the vertex is 4, comma, negative 18. All right, so the range. Well, this thing opens up, right? If it opens up, the range is always greater or equal to. Y is greater or equal to, and we just take the y value from the vertex, which is negative 18, right? The lowest height is negative 18. Axis of symmetry. Well, axis of symmetry, we always start off by saying x equals to, and it's just the x value of the vertex, which is 4. So the axis of symmetry is just a line that cuts the graph in half. So this vertical line right here, this is x equals to 4. That's the line that cuts the graph in half, so that we have symmetry on both sides. X-intercepts. All right, hopefully this one's not too bad. We can look at the graph here. We have an x-intercept here at 10, 0. So 10, 0 is our first x-intercept, and we have another x-intercept over here at negative 2, 0. The y-intercept, we have one y-intercept over here, which is 0, negative 10. And since this parabola opens up, we have a minimum value. So the minimum value equals to, well, the lowest height that we have is negative 18. And then finally, we need to find the equation of this particular parabola here. Okay, so for this particular question, we know the vertex is 4, negative 18. So we can always start off by writing a bracket x minus p squared plus q. And since we know the vertex, we can write this in. So x minus 4 squared minus 18. Right, and then from here, all you have to do is kind of look at the pattern here, right? So we go over 1, up a half, over 2, up 2. Okay, so it looks like the heights here are being split in half, right? So that means the a value has to be 1/2. All right, so there's your equation right there. Okay, let's see if we can do a few more. Go to the next page here. All right, so let's write a few questions where now we need to write the equation of the parabola. So the parabola, we have y equals to x squared, and it undergoes the following transformations. It's reflected over the x-axis. Okay, so if I'm graphing y equals to x squared, this is a graph that you just need to know how to graph. This is the basic graph of a parabola like that. And if it's reflected over the x-axis, here's your x-axis, that means we want to reflect this down there. So that means our new graph looks like this. That's what we call a reflection across the x-axis. And now this equation will be y equals to negative x squared. And then it's translated 5 units left, right? So if we're going 5 units left, 5 units left, we need x plus 5. And 2 units down would be negative 2. And then we're compressed vertically by a factor of 1/2, right? So our final equation will be y equals to negative 1/2 bracket x plus 5 squared minus 2. All right, so that question you can really kind of do in one particular step, and you just need to understand the transformations here. Okay, let's move on to the next one. What is the equation of the parabola with vertex that and x-intercept of this of 3? So when you have an x-intercept of 3, that literally means the x value is 3 and the y value is 0. So that's the definition of of an x-intercept. That means y equals to 0. Okay, I would start off with the general equation of a parabola here. So a bracket x minus p squared plus q. Okay, so we know the vertex is negative 2, 5. So y would equal to a bracket x plus 2. Remember, that's always the opposite sign, squared plus 5. So insert the vertex. And then we know the y and the x values, right? The y value is going to be 0, which is this value right there. And the x value is going to be 3, which is indicated by that value there. And then the plus 2 squared plus 5. All right, now we solve for a. So 0 equals to a bracket. Well, 3 plus 2 is 5, right? And 5 to the power 2 is 25 plus 5. Then the 5 goes the other side, becomes negative. I have 25a. You divide both sides by 25, so I get negative 5 over 25. And that's equal to 1 over 5. So final answer here is y equals to negative 1 over 5. Bracket x plus 2 squared plus 5. All right, so there's your equation. All right, so this next particular question here, we need to graph the quadratic equation by first completing the square. All right, so I have a leading coefficient of negative 2, so let's go ahead and factor out the negative 2. So I have x squared. I guess it's going to be minus 3x. And then we always have a plus sign there. And then what we do now is we take our middle number, which is negative 3, we divide it by 2, and then we square it. And this will give us a fraction, right? So this will be a 9 over 4 plus 7. And then the tricky part here now is we need to multiply the leading coefficient with the 9 over 4. So that's going to be negative 18 over 4. All right, so to undo that, we need to add 18 over 4. Okay, so there we go. That's the first part of completing the square.